And today we're going to discuss the beer system basics. Again, I got a hard show to follow with Corinne doing a great job on all the other presentations. Um, this is again intended for trainings with your dealers, and it's just a broad brush on some of the things that make beer systems that Perlick manufacture different than our competitors. So let's get started. Beer system basics. Things to think about when you're selling a beer system. Today, beer systems, as years ago, all you did was beer. But in today's market, we have ciders and wine and mixed cocktails and coffees, and everything's being dispensed now through a beer system. And that's why, if you notice lately, we haven't been calling them beer systems, we've been specifying them as beverage systems. But with that said, we are going to focus today strictly on beer, in that's the majority of what is dispensed. As you know, draft beer is the most profitable adult beverage when served at the bar. Customers like the fact that they have draft beer. It gives you great variety. The reason people do draft beer is because it's considered the freshest and the best product you can get. Product beer and that out of cans or bottles just don't taste the same as when you get a draft beer. Plus, it's the feeling of watching a person pour the beer, serve the beer. It's a whole experience. What is the proper serving temperature of beer? Well, that's an amazing thing to me. In all the years I've been working with the Perlick Corporation, it amazes me that people aren't even aware of what the temperature of beer is supposed to be served at. And there's a very specific reason why beer is served at a given temperature. Most domestic beers, like your Coors, your Buds, your Bud Lights, your Millers, all are served between 36 and 40 degrees Fahrenheit. And that's because at that temperature, the CO2 is coming out of the beer and is released from the liquid at a very given rate. The colder the beer, the more the CO2 stays in the beer. The warmer the beer or liquid, the faster that CO2 is going to come out of that liquid. And at 38, 42, we know exactly how fast that's coming out, which enhances the flavor of the beer. I know there was a craze for a while, and there's a little bit of it today, wherein people are saying, well, wait, I want to serve 32-degree beer. Well, keep in mind with what we just talked about, at 32 degrees, that liquid is very cold and it locks all that CO2 into the liquid. So then what happens is you drink that beer at 32 degrees, all the CO2 is locked into it. Hopefully your body is 98.6. Once it hits your stomach, it releases all that CO2, and all of a sudden you're burping because you're filled with CO2. They actually found out that customers will eat and drink less because they feel full. Well, they're not full of product, they're full of CO2. And being that we're trying to get profits, we want our customers to drink reasonably, so we don't want to serve beer at 32 degrees. The other myth is, and the question that comes about is, well, how should I drink my beer? Should it be in a can, a bottle, or a glass? Well, again, we can add to that by saying you never drink beer out of a can or a bottle. You always drink it out of a glass. And that's because 78% of taste is smell. And that's why it tastes different. And that's why you're supposed to drink out of a glass, so that you can smell the CO2 coming out of the liquid, which carries the flavor and enhances the taste. That's why a lot of times when you have a sinus infection or a bad cold, you don't feel like eating and drinking because there's no taste. And that's due to the fact that you've eliminated the sense of smell. And it's very important to have that and to increase the taste of the product. In fact, Samuel Adams, they didn't trust a lot of the bartenders. And so what they do is they serve their beer in a Samuel Adams glass. A lot of people think they do that just for marketing purposes, and it's not. The glass is very specifically made for their product. Here's an example of a Samuel Adams glass where you can see how it's narrow at the bottom and then it bowls out. and then it comes back in, but then it bowls out again so that you can get your nose down into the product when you're drinking. The glass itself, if you look at the bottom, there's a little etching at the bottom of the glass, and that's to create a little bit of agitation, so it releases that CO2. So again, when you're drinking, it comes up through the liquid and you smell it, which enhances the taste. People who sell smallware should look at these next couple slides because different beers require different styles of glassware. Each one is going to give the customer a better experience based upon the beer that you're serving. And so there's a couple slides that you can discuss with the customers to show them that, hey, you can't have one glass serve all. You got to have a specific glass for a specific beer. Let's take a look at the foam or the head and what's the purpose of it. A lot of people think it's to increase profits. Yes, it does, but that's truly not its original intent. A properly poured beer should have about 1 inch of head or about 2 fingers width. The head actually keeps the CO2 in the liquid while you're not drinking it. So in other words, the glass is sitting flat on the bar top, the head's across the top of the liquid, the CO2 is not able to escape, it holds it into the liquid. Then when you pick it up, the head comes forward, letting exposure to the liquid, CO2 starts coming out, you breathe it, and that's what enhances the flavor. In fact, in Boston, they tried 2 times now to pass a law stating that you can't have any head on the beer. If you're advertising a pint of beer and you have a head on it, you're not giving the customer a full pint. It has not passed the last 2 times, and I don't think it ever will. The reason it's coming up is because, again, nobody understands what the function of the head on the beer is. Keeping in mind that foam is 25% liquid and 75% CO2. That's what makes me crazy sometimes when you're sitting at a bar and you're watching that bartender throw all the foam down the drain and then they finally pour liquid. That's profits going down the drain. We don't want that. The understanding is too that the bartender puts the head on the beer, not the system. But bartenders are so used to inferior systems that foam immediately when they come out of the faucet, they think that's normal, but no, it's not. You should be pouring a solid liquid, then you set the glass down, you drop the liquid into it, that creates agitation. The agitation then creates the amount of head on the beer. So if I look at all these different glasses, I can tell, just looking at them, I can tell you that either one of 2 things. 1, you had an inexperienced bartender who didn't know how to pour a beer, or 2, the system was not designed properly and not pouring solid liquid, and it was foaming coming right out of the faucet. So other facts that can affect the beer is beer clean glassware. That was a long and has been a long-standing issue with Perlick. All systems start with a beer clean glass. I don't care if you spend $20,000 or $100,000. If the glass isn't clean, you're not going to be able to pour a good carbonated drink. That's because grease, oils, fats can all affect the quality of the carbonation. In fact, what I tell people is when you're sitting at the bar and you see all these little bubbles stuck to the side of the glass, CO2 sticks to dirt. So don't get excited when you see all them little bubbles because you think that's the way it's supposed to be. It's not. Again, CO2 bubbles stick to dirt. I will send a glass back if I see all those bubbles stuck to the side and tell them to give me a clean glass. Etch glasses. As you know, a lot of times there's not enough room in the bar for glassware. We didn't plan ahead. So what they do is double stack them. Well, when you stick one glass inside of another glass, it causes scratching and etching. Well, that can cause agitation. So when you're pouring the beer in and it hits all those scratches, it agitates it and causes it to foam. You may have to replace your glassware only because of the fact that they're too etched, they're too scratched, and it won't give you a good product anymore. Lipstick, chapsticks, again, will leave rings of fats and oils. That's what's in lipsticks in chapstick, which will break down the CO2, cause it to go flat, and cause issues with the product. Bars that serve hamburgers and French fries and greasy chicken wings, again, these are all potentials for having issues with your glasses because as you're handling the food, you're touching your glass, it gets on your mouth, and then all of a sudden it gets into the glass itself. Alcohol content can affect the head on the beer. Certain beers that have higher alcohol content are a little harder to get the head on the beer. Temperature definitely is an issue. If you don't have the right temperature, it affects the CO2, it affects the taste, and it affects the customer's experience drinking the product. There's one thing that customers really understand, and that's profitability and ROI, return on my investment. There's a sheet that we have available, a brochure, and on the back of it is a great example of how foam affects your profitability. And for instance, if you did 8 ounces of foam, and you did that 50 glasses a day, and you did that 7 days a week, 365 days a year, and you charge $4 a glass, you would throw away approximately $15,600 in profit. Average beer system's $20,000. So what's the ROI? With a properly balanced system that maintains temperature, it's within the first year. And so again, explaining this, understanding these theories and concepts is important. Beer systems are more than simply an attractive tower. But when you're talking to the customers, most customers focus on the towers because that's their image. That's what they're going to see every single day. The trunk line, the power packs, the pressure source become secondary because their focus is mainly on the tower. And different towers, different shapes, everybody wants to be different. They don't want to look like the guy down the street. They want their customers to have a different experience when they come into their facility. Here's a place that's right up the street from me in Texas. It's for the Cowboys, which we don't mention too often, but the Cowboys wanted, again, something different, something that everybody else didn't have. So we incorporated the star. It gave it a different look. It gave it a different appearance. The thing today is a lot of people are cantilevering them off the ceiling. That's become real popular because then you don't have the extensions on the bar top. It's easier to clean underneath, and it gives you a little bit more storage. Radius, again, something different, something that looks like like the place down the street. And so let's take a different look at ways we can dispense draft beer. One of them is through a direct draw. One's through utilizing the cooler that's in the restaurant and doing wall mounts or air shafts. And the last one is long draw systems, remote systems, glycol systems. It has multiple names, but we're all talking about the same thing. And so if I look at keg boxes, why do people buy keg boxes? It's easy to clean. I can use straight CO2. Little product loss during cleaning because the lines are short. You don't have, 50, 300, 600 foot lines. So every time you clean, you have to throw all the beer away. And it's great for places that have patio bars or pool bars because I can roll it out, serve my beer, and push it back in again. It also allows you to have some variety in flavors, but if you're going to go more than 6 or 7 beers, it kind of forces you to go into a long draw system. But if you're just going to have a couple different beers on tap, again, it's a great alternative for dispensing beer. Very simple, don't have a lot of moving parts. You got your tower, your faucets, your tubing, your coupler, and your pressure source, and then you can put your multiple kegs in there for different varieties of beer. Here's an example where they actually used one and put glass doors on it to help market the product. Again, dispensing heads and that are about marketing. What do I have available to the customer to serve them? So what we'd like to talk about a little bit is, so how do I approach the dealers? Always ask for a quote, the beverage system. Even if they say they are getting it for someone else, they may not truly understand what it takes and what's necessary to do a good beer system. Before you present to the customers, the dealer, we should take the rep with. They may be able to you may have some questions that you can't answer for the customer, and our reps are highly trained in beer systems. They understand them from one end to the other, and they may be able to contribute to the conversation. Cost is always a factor. The wrong system can be costly mistake for your customer. beer slash beverage systems are still the most profitable in the bar and restaurant. But if you buy the wrong system and it doesn't give you the proper yield, it's costly. It's going to be expensive to run and operate. So let's take a look at the different systems that are available. First one is air-cooled. Why do people want air-cooled systems? Well, a lot of times they want it because it's a inexpensive solution to dispensing beers. Venues with with coolers that maintain temperatures between 34 to 38 degrees are candidates for this product. The only restrictions really are that you can't have a beer tower more than 25 feet or less. The operator wants to offer a wide selection of beer. This isn't a good solution for them. Or it can be to a certain degree in the fact that you can go through the wall. One of the big changes we made about 4 years ago, in the past, we used to say, if you want to do air cooled or air shaft, we give you a catalog, here's the parts, order them, somebody installed them, and we hope they worked. Well, as the beer experts, we said that that wasn't proper. So now we factory engineer our air cooled systems just like we do our Sentry systems. We guarantee that they're going to work. We guarantee that they're going to be installed by an authorized installer who knows how to install an air cooled or air shaft system. With that said, there are challenges with air shafts and air cooled systems. Whether it's through the wall or if it's an air shaft, it has to be designed and engineered the same way that you do with a Sentry system. How much lift, what's the distances? These are all parameters that need to be addressed when you're designing and engineering a air-cooled system. Looking at through the walls, running taps through the walk-in cooler wall is a real common thing today. It's a very cost-effective way, again, of dispensing beer, but it's not without its challenges. A Perlick through the wall kit includes everything the installer needs to run the beer system through the cooler. Keep in mind, faucets are sold separately, and so you got to make sure you include that into your quote in your price. Selecting the right shank is important. A lot of people in the past, what they would do is order the longest shank they could get, 12 inches, 16 inches long. But keep in mind that is now a heat load. And so the longer the shank, the more cooling I need in order to keep everything at 36 to 38 degrees. So you want those shanks as short as possible. Here's a quick reference chart for you that shows you a couple examples. For instance, if I had a walk-in cooler, and normally they back it up to the inside bar wall. And so what I'm going to do is I'm going to drill through the cooler. I might have a little bit of a space between the cooler and the wall and then through the wall. Well, if that distance is 3 to 5 inches in thickness, you will get an 8-inch shank. I wouldn't put a 12-inch because, again, I'm putting more shank in the cooler than I actually need, and that's another thing, again, I got to cool. And so understanding that, getting those dimensions are very important. Another alternative is I have dispensing heads that are module wall mounts. I've seen these mounted above back bars. I've seen them free hanging, so it gives the customer a lot of options. You can do up to 32 faucets. It's 96 inches long. You can include glass rinsers on it if you wish. Again, understanding the function of a glass rinser. A lot of people don't understand what they do. A glass rinser's main function is to wet the interior of the glass to make it slippery so that you don't create friction, which again can cause foam on the glass. All the faucets are on a 3-inch center. The beer leads come off the back and into the walk-in cooler. The system will be restricted and engineered by us at the factory. It's easy to install. It's made heavy gauge, 14 gauge, and it's insulated. We got a competitor's tower that is pretty close to what we're supplying, and they were sweating all over the place because they did not insulate behind the faucet shanks. You're blowing cold air in. You also have to have a cold air out. That was another thing we found with the competitors. They were blowing cold air in, but there was no way for that cold air to come back out, which means it limits the circulation, which caused hot spots. So the faucets close to where the air came in were cold. The ones on the opposite end were warm and causing all kinds of foam. We've expanded our offering to give you more variety. So here's a pipe tower that's air cooled. So one of the legs is bringing cold air in. On the opposite end, the cold air is coming back out to keep all the faucets at 36 to 38 degrees. And here's just another view of it. It looks pretty good. So that walk-in cooler is on the other side of that wall, and we have the blower and the hoses all connected to it. The last air-cooled system is what we call the air shaft. These were very popular in the 60s when your walk-in cooler was in the basement, the bar was right above it. All you would do then is hook up a blower to the evaporator and then blow cold air up to the tower. Well, it's a great system. It can work, but ultimately you got to make sure you're less than 25 feet. Traditionally, what will happen is the bar, again, the walk-in cooler from where the line comes out of the walk-in cooler to the center of the faucet has to be 25 feet or less. Once you get over 25 feet, that air warms up as it's passing through the tower and you don't get proper temperatures. If you looked at the drawing on the bottom, you see little blue arrows and red arrows. That's a double wall tube, so it's a tube within a tube. So we're blowing cold air through the center. It goes up into the tower. There's a diffuser up there that diverts the air back into that tube, and it goes on the outside of the tube that's feeding the cold air in, getting it back into the walk-in cooler. One of the things that we should always recommend that you buy is that item number 8, and that's the elbow. We're saying 25 feet, but there's a couple things you got to watch. Number one, you got to know the layout. So when that walk-in cooler, if it's against the wall and it's coming into the bar, you got to make sure there's not like a storage cabinet or a bottle cooler or a mug chiller, because coming out of that wall, I got to be able to travel all across the bar drywall to get up to the tower. So if there's anything that's too low, I'd end up having to cut holes to get the trunk line through. Well, that's not a good thing. And so looking at the layout, making sure we have a clean path, that their work boards or the heads close to that walk-in cooler wall. And then providing that elbow allows you to go to 25 feet. You don't have to use it. You can just bend that tube, but you're going to lose about 2.5 to 3 feet. So now I can't go 25 feet. I can only go 22 feet because I have to allow for the radius of that bend. So that's just a few things you need to look for. The other thing is the blowers. Blowers have to be within a maximum of 12 inches from the discharge of the evaporator in the walk-in cooler. The challenge with that today is there's two things. Number one, a little more coordination. You're going to have to make sure there's an electrical plug or some kind of electrical box on the ceiling to plug that blower into. The second thing is some of these cooler manufacturers have now gone with bottom discharge. In other words, the fans, instead of blowing straight out, they're blowing down towards the floor. Well, now I have to modify the blower assembly in order to mount to the evaporator housing instead of the ceiling of the cooler. So we got to kind of keep an eye out for that. Here's all the standard towers that Perlick offers, but again, we have been expanding these lists, and so there's more product offering now for air-cooled systems. Remote. What components do you need? Well, here's a picture. Yes, this is everything you need to do a remote beer system. It's kind of intimidating. The average customer will look at that and go, wow, I don't think I want to get involved. It looks way too complicated. So we want to make people's lives easier. There are 5 things really we need to know from the customer. What kind of tower you want and how many faucets. Beverage, your beverage or trunk lines, you need to have one of those. You got to have your power pack. You're going to need a pressure source. And the 5th one is a walk-in cooler. A lot of people get confused by number 5 because we don't sell walk-in coolers. So why do we need to worry about it? Well, there's different kinds of walk-ins out there. Today, there's walk-in coolers that are set to be at 32 degrees. Somebody's convinced the market that if you store your beer at 32, it will pour better. Well, we can modify our system to accommodate that, but we need to know that going in because it's going to affect the design of the system. One job I did down in Mexico, I did a Buffalo Wild Wings. not knowing and didn't look at the temperature of the cooler, found out that every day at noon, the beer wouldn't pour anymore. That's because low temp 32-degree walk-in coolers go into a defrost cycle at least twice a day. Well, every day at noon, it was going into defrost, warming up the cooler, warming up the liquid, and causing the beer to foam. So we had to recalibrate the defrost cycle. A dedicated cooler is what we'd like to see, but we know in the real world that's not always possible. So we're going to share a cooler with the food. That can create problems also because the food truck pulls up, they throw the curtains over the door, they leave the door open now for a couple hours while they're loading it with food, causing everything to warm up. What people don't understand is liquid warms up twice as fast as it takes to cool it down. That can create a problem, especially if they don't order their beer in time. Today, beer distributors got rid of the refrigerated trucks. And so what happens is they put the beer on the truck at 8 in the morning. It's Atlanta, and the beer's at 38 degrees. You're to 2 o'clock delivery. It's 110 degrees. By the time you get it to the bar, it's now 44 degrees. Liquid warms up twice as fast as it takes to cool it down. So as an example, that 44-degree keg, I would have to put it into a 38-degree cooler for a minimum of 24 hours to pull all that liquid down. Only took 12 hours to warm it up, but it takes 24 hours to cool it back down to serving temperature. So the question now becomes, isn't all beer towers the same? No, they're not. Perlick offers the best towers out there. All the towers we make have a heat exchanger in it, and that's that cold block. It's made out of a product called Kirksite. It's a special material that we order. It has great conductivity for temperatures. It maintains temperatures. So in that block, if you cut it open, you would find the copper tubing, which runs the glycol. So I'm cooling that whole block down, which the shanks are embedded into, which gives me great cooling effect from the faucet all the way back to the cooler. In fact, I've had customers call me up and say, hey, Tom, there's something wrong with my system because my faucets are sweating. My response is great, because if they're sweating, that means they're cold, and the system is doing exactly what it was designed to do. We insulate it, we foam it in place. This will eliminate the sweating of the tower itself. A lot of people, what they do is they just stick fiberglass insulation in there, or they'll try to create that system, but not to the extent that we do it. Here's an example of one of our competitors. So instead of that Kirksite block, they just have little brass shanks, and then they take a piece of copper tubing, just like we have, that goes back to the glycol chiller. They just touch it, and so that's your cooling point, is where that copper touches it. Then on the right, they show you, yeah, and then we foam it in place. In fact, they say that in their literature. Well, that's all they foam, is that little head. Now they'll take that, drop it into a shell of like a T-tower. Well, all that air in that cavity of that T-tower is heating up. Just that little section there, which I call the Twinkie, is being maintained cold. Faucets. If you don't talk about anything else, at least talk about our faucets. We have the best faucet in the market. It's patented by us. It's designed by us. And we made this faucet to answer the problems of what was going on in our industry. Today, you have to clean your beer system every 2 weeks. Part of the cleaning procedure is you got to take the faucets apart, wash them, sanitize them, and put them back together, because of the fact that the way they seal today in the old days is the liquid used to shut off right back where by the threads of the shank. That means all the components in that faucet have exposure to oxygen, which causes a second fermentation process. It causes mold to build and bacteria to grow, and the faucet needed to be taken apart and cleaned. Well, we moved that seal point from the back by the shank all the way forward to the spout. What that does now, there's solid liquid in the shank area, so the air and oxygen can't get in there. You don't get that fermentation or the bacterial growth. We designed the faucet spout to pitch away from the shanks at a very specific angle as not to break up the beer and cause foaming through the spout. And it takes all the residual beer that's left and allows it to drip into the drip pan. It's all stainless steel. Today, again, we don't know what you're going to dispense. If you're dispensing wine or ciders, they require stainless steel. Our faucets will meet those requirements. Here again is the old style faucets, and that piece that you're seeing is the one that would cause all the trouble. That little slot was a perfect spot for bacteria to grow. Well, we eliminated that. There is no little stem in there anymore, so we don't have that bacteria potential. Here's a sample showing you exactly how the liquid sits inside of that faucet, preventing oxygen and air getting into it. Another feature is our flow control faucet. So in the up position, the faucet's wide open. When you press it down, it's in the off position. So why do we have a flow control faucet? What is its true function? One of them is if you have a microbrewery and you give tours, a lot of times we'll give you samplings, and those samplings can be sometimes 4 ounces or 5 ounces. Well, when the beer's coming out at 2 ounces a second, trying to pour those little samples is almost impossible. And so what the flow control faucet allows you to do is close it off, slowly open it, fill your sampling, and then give it to the customer. Once they have their sampling and they want to go back and get a pint glass, then you open the faucet wide up and you've got a full functioning faucet. The other thing is for growler and growler filling. So that little piece you see in that gentleman's hand, that tail piece, took thousands of hours of engineering. And it's very precisely engineered and designed. What you do is you stick it in the outlet of the faucet. That plastic tube goes into the bottom of the growler. You're going to fill the growler from the bottom up. Because it's going to open up into that expansive area inside the bottle, you are going to get some foam. There's no way of stopping it, but it's minimized once the tube gets under the liquid. As the bottle fills up, that little bit of foam you got is going to want to come shooting out at 128 ounces a minute. And so what this does is it allows you to slow it down, so when the foam comes out of the bottle, it comes out gently and doesn't shoot all over the place, causing a mess. For a little side note, anybody know where growlers came from? Well, it came back from the 50s when Dad used to stop off at the bar and have a drink or a beer before he'd come home for dinner. You want to take some beer home with them, so they used to fill up a metal bucket with a lid on it. Dad would be walking home, swinging the bucket, causing agitation. It would lift the lid and create a growling noise, and thus was born the growler. So I thought all trunk lines were made the same. Yeah, well, not exactly. Perlick's is designed and engineered, built and manufactured in Milwaukee, Wisconsin. Perlick uses half-inch copper tubing for its coolant lines. All of our competition will beat up Perlick on using copper. They say that's old school. You don't need it. It's too hard to pull through the system. It causes all kinds of issues. That's not 100% true. We use copper because of the fact that it does a better job at cooling. I get more efficiency out of copper. What that efficiency does, it allows me to downsize my power pack. I don't need as much cooling because I use copper coolant lines. As far as being able to pull it through the system, it's not the copper that's causing the problem, it's the way we wrap it. If you come to the factory and you see the machine that wraps that reinforced tape to hold all them tubes together and maintain conductivity to the copper tube, it pulls it like a banjo string. It's very tight. So when you take a bundle and you have copper tubing and you try to move, if those tubes can't move, it makes it very rigid. So it's our taping that causes rigidity, not the copper tubing. We can put up to 24 beverage lines in a bundle. When we do that, we'll go up to 4 coolant lines because we always want to make sure the beverage lines touch the copper. So we'll do 6, 6, 6, and 6. We can go up to 650 feet on a single run, which is unique to Perlick. We offer tubing in 3/8, 5/16, and 1/4 inch. Why do we do that? Well, there was a competitor out there telling customers, hey, you're buying 3/8 tubing, beverage tubing from Perlick, and every time you clean your lines, you're throwing that beer away, and it's costing you a boatload of money. If you go down to a smaller ID tube, you can save money. That is a true statement. But what they don't tell you, you can't go 650 feet with 5/16 and a quarter-inch tubing because it's because of the smaller ID. It's got more resistance, more restriction, and it limits you to how far you can go. So yes, can I go with smaller ID tubings? Absolutely, but you got to look at the job site. You got to see how far the runs are in order to be able to downsize those tubings. All of our tubing is NSF approved and it's fire rated. If you have a situation where you need to have a fire certificate, contact us and we can get you a copy of it. PVC outer lining, we use 3/4-inch Armorflex insulation. All the beverage lines are numbered. The reason we do that because it corresponds to the numbers on the towers. So going from left to right, if I had a tower with 8 faucets, the first faucet would be number 1, 2, 3, and 4, and there's little numbers above each faucet. So if faucet number 3 goes down because it's empty, the bartender knows when they walk into the walk-in cooler, we always again go from left to right. The third line coming down will say number 3. It'll go to keg number 3. So it's easier for the bartenders to find and replace the keg. For a nominal fee, we do also offer a sleeve or jacketed trunk line. That's for if you go, especially going underground, you want to make sure that we can protect our bundles. We do have tape, vinyl tape wrapped around the exterior, which helps, but it's not waterproof. So these jackets allow you to go under the ground. Sometimes that conduit underground will crack, groundwater will get in, so it will protect the bundle from permeation of the groundwater. We only jacket the part that goes underground. Once it goes, so when it goes in and comes out, that part under the ground is jacketed. Everything else is just a standard trunk line. Again, why do we use copper tubing? If you look here, the thermal conductivity, we're 385 compared to plastic, which is 0.02. Again, we don't need all the BTUs on our power packs because of the fact of the way we build our trunk line. The fact we use copper for coolant gives us more efficiency. Add in the heat exchanger in the head, you've got a home run all the way. The other thing is we don't have bundles of trunk lines sitting around waiting for customers' orders. Every bundle is made at Perlick based upon the specifications of the job. Not all jobs are the same. You don't need 500 feet all the time. And so once it comes into the factory, the system gets engineered, we factor in all the resistance and restriction in line, and then we build that line according to the specifications of the job. One recommendation I have is if you have an 8-line or 8-faucet system, it's not a bad idea to add an extra 2 or 3 lines to the bundle. Say you got a customer says, hey, I don't know if I want 8 faucets, 12 faucets. It gives them an ability if you want to change later on because sales are great and you want to add more variety. I don't have to change the whole system. All I have to do then is change my tower because I have a couple extra lines sitting in the bundle. The other thing is seasonals, like pumpkin beer. Once you put pumpkin beer in a line, you can never ever put anything else into it because you'll never get that pumpkin out. Root beer, same thing. So again, if I have a seasonal beer, I can run it for that season. Once the season's over with, I can disconnect it, take the extra line I provided in the bundle, and then attach that, and I can put another beer in the system. Here's a sample of a competitor's trunk line to give you some input. If you look, the blue tubes and the red tubes you see on the left-hand side, those are their coolant lines. Now, on the outside on the far right, you see 7 lines that aren't touching, or actually 3 lines that aren't touching those coolant lines. Those have no chance of maintaining 36 to 38 because they're not touching your coolant lines. They also tell everybody that you don't need copper. You can just, it's an overkill. But if you look on the right, what they do is they wrap the outside with tinfoil. They want that metal to help in the cooling process. Well, if you don't need copper, why are you wrapping your bundle with aluminum foil? And the other thing when selling, if you think about it this way, The heat exchanger and the towers have copper tubing running through it, and that's running the glycol. When you look at your power pack, the heat exchanger is made out of copper. If copper is important on your power pack and copper is important on your tower, why would you connect the two using plastic tubes? Plus, our competitors have a maximum of 20 lines in a single bundle. We do 24. So what makes our power pack different? Good question. First of all, it's all stainless steel. A lot of our competitors are either painted or black vinyl clad. And you're going to be putting this into a harsh environment. It's going to go in the kitchen where you've got all kinds of things in the air that can deteriorate the outside. We have electrical temperature control that measures the inbound glycol temperature. This is important. If everybody else measures the glycol temperature of the bath, well, that's telling me what it's going out at. It's not telling me what it's coming back at. I want to know how warm or how much heat is that power pack removing from that bundle in the tower. If I'm sending it out at 32 and it's coming back at 44, I know I got a problem. And that little thermostat's going to read 44 degrees. And so it's kind of like a troubleshooting. It's helping our customers realize if there's something that's gone wrong with the system. High efficiency heat exchanger, and I'll show you that in a little bit, and we'll cover that. Pumps that run 24/7. A lot of companies, what they do is they cycle the pumps on and off, on and off. That's a lot of wear and tear on the pumps. Ours run 24/7. They're all top mounted pumps. You can go from 1 to 3 pumps. When you put 3 pumps on the larger units, that's running 3 different trunk lines. Again, you want to spread that heat load out as much as possible. We don't want to run 1 pump and go 600 feet. We'll use 2 pumps and do 300 feet apiece. So it's an advantage having multiple pumps. Sealed bath, so it locks out the condensation that comes from the high humidity within the air. We offer different sizes, different voltage. They're all NSF approved. The glycol that we put in there is already pre-mixed, so you don't have to mess with it, and it's food grade. Here's that heat exchanger we talked about. Because of its efficiency, we only have to put 1 3/4 gallons into the glycol bath, and it's all stainless steel. The reason that it does that is if you look at that plate, that copper thing there, it has multiple plates in it. So the first plate has refrigerant going through it, the second plate has glycol, then the third plate refrigerant, fourth plate glycol. So it's like a huge radiator. And because it does that, it gets in direct contact with the refrigerant, it pulls down the liquid very, very quickly. A lot of our competitors have 11, 12, 15 gallons of glycol. And you know how much glycol is. So just the startup alone, you're spending more money. If the glycol has to be replaced, you got to replace 11, 12, 13 gallons of glycol. That's a lot of money. Here's an example of a competitor. It's not stainless steel. Temperature displays only the temperature that's within the bath. The copper tubing is wound around in the bath, and that's what does the cooling. It has a huge plastic tub that holds 11 gallons of glycol. That's not including your trunk line. That's just the bath itself. So how do we determine the correct pressure source? This is always a difficult topic because pressure sources are based upon design, how the system is laid out, what type of products you're going to pour. And so there's a lot of variables that come into the pressure source. My recommendation is, here's the simple answer. The correct pressure source is critical to maintaining the product quality. We want to match what the brewery put into it. That's what we're trying to do. This propels the beer from the keg to the faucet. The optimum pressure source is dependent on the design of the system and will be specified by Perlick. We have reps, we have engineers that have been doing this a very, very long time. And we are best ones in the position to tell and specify what kind of pressure source you should use based on everything that we just talked about. Knowing that there's straight CO2, you can get beer gas, alley gas, it's all the same thing. In other words, the gas is already nitrogen and CO2 mixed into a bottle. You can blend your own on site. Beer pumps entered us into a whole new market. Prior to beer pumps, the maximum you could go was 300 feet. Beer pumps today took us to 600, 650 feet. Madison Square Garden, we got a system out there that's over 700 feet long, but all the stars and the moon and everything have to line up just perfect to make that happen. And that's why I recommend that, hey, call us in. We'll help you determine what pressure source to use. So if we just do an overview of everything we just talked about, these are the hot points. Factory reps help you design and quote the system. We make it simple for you. Those 5 things that we talked about in the beginning, that's all you need to know in order to get the system up and quoted. A job site visit. We're going to come out and check the field conditions. We're going to check to make sure that everything is where it's supposed to be. A lot of times you go out to a job site and all of a sudden you run into a column and the plumber had to go around it. That wasn't on the drawing. That was never revealed to us. That's why it's important to do a final field inspection before you build the system. Every system is reviewed by the engineering in the factory and designed to ensure system performance. We're going to factory restrict it. We'll make sure that everything is the way it's supposed to be. You're going to get all the parts and components you need to build a complete system. All systems are installed by factory trained installation companies. Another thing that's important, our installers have to be recertified every 3 years. Nobody else in our industry does that. And so in order to maintain qualifications to become an authorized installer, you must be trained in Perlick, Milwaukee on how to install a Perlick beer system to our specifications. We stand behind our systems with performance guarantees. We do the design and engineering for you. There's nothing you have to worry about. Add to that, we're going to keep a record of it. It's not after we sell it, we forget about it. We're going to hold on to those records in case you ever want to add another station. Say you want to add more faucets. We don't have to reinvent the wheel in order for you to do that kind of work. One of the other things is a lot of people, they, again, especially customers, want to see what's available. What are other people doing? Are there other options? What else can I do? Seeing it is a lot different than talking about it. So what I did is I added some really cool towers, and I think a lot of these came from Corinne, but show these to them. This is a great, great tool for them to take a look at. Wow, in other words, you can do that? Yeah, look at this one. It's a T, for God's sakes. It's pretty awesome. The old Gambrinus towers. We did multiple versions of these. We did one for a race track where we took the king off and we put horses on top as an option. And so we can customize things to meet the customer's decor and their demands. So they're here. We're not going to spend a lot of time on them, but it's a great little, hey, look at this. We had a question on this one this morning saying, well, what the heck is that? Why is it mounted to a table? Well, again, there was this little thing going around where self-serve. Swipe your card, pour your beer, away you go. Some of the challenges with that, though, are we got difficult time getting and educating bartenders how to pour a beer. Now you got a customer who doesn't have any clue, and they're pouring the beer. So making sure that the system works is very important. Thank you. And is there any questions?
I guess there's no questions.
I guess we did such a great job